How do we recover valuable resources from industrial waste? Greek scientists have developed a new technology to extract rare earth metals from spent ore in a sustainable and environmentally friendly way. This aluminium of Greece plant processes vast local deposits of bauxite ore. Each ton of aluminium spawns 1.6 tons of bauxite residue, often called red mud. For one of the largest plants of its kind in Europe, that means around 2,000 tons of fresh red mud are produced every day.
One might imagine residue is waste, but for us it's an ore for the future. This bauxite residue contains iron, titanium, silicon and rare earth metals like scandium. In the future, this will be the main ore to produce all these elements.
Rare earth elements are especially valuable. Sometimes called vitamins of metals, these elements drastically change properties of materials. This makes them irreplaceable in the manufacture of wind turbines, cars, computers, smartphones, and other high-tech applications.
This particular bauxite residue contains around 1.5 kilograms of rare earth per ton. This may not sound very impressive until you do the math. Add up 700,000 tons per year, and we're sitting on 10% of Europe's annual demand of rare earths.
What is needed is a cheap and clean way to extract these coveted elements. It's one of many goals of a European research project that looks to alleviate Europe's total dependence on imported rare earths. Engineers in Athens have developed a simple method to dissolve and remove rare earth elements from red mud.
The major advantage of this process is that it can take out rare earth elements selectively. It doesn't dissolve the whole solid matter, just the elements that we require. That is an economical and environmental advantage.
The key is using an ionic liquid rather than more traditional solvents. Ionic liquids are molten salts that can stay liquid at room temperature. Researchers weigh some red mud powder. This is the same waste from aluminium production in dry form.
We're going to pour the bauxite residue into the reactor that contains a solution of ionic liquid. The way this leaching works is similar to making tea or coffee. You basically extract the components you need.
It takes a couple of hours for the rare earth elements to be completely dissolved in the ionic liquid. The mix is then filtered to remove the solid residue that can later be recycled. Finally, some acid is added to restore the ionic liquid back to its original state, ready to be used again. What's left is the valuable extract of rare earth elements.
What properties of ionic liquids give them advantages over traditional solvents?
They are superior because ionic liquids are non-flammable and non-volatile, so we can work with them at higher temperatures without any fire or health hazards.
These powerful solvents of the future can be individually designed, with their chemical properties fine-tuned, opening a way to a more sustainable use of fossil resources.